Our focus standard for this lesson comes from Grade 8 Expressions and Equations, Standard 8. Analyze and solve pairs of simultaneous linear equations. Our topic for this lesson comes from Systems of Equations, Equal Values Method for Solving Systems of Equations. Our essential question is, how can we solve linear systems without graphing? Please take a moment, pausing the video if you need to copy the standard, the topic, and essential question into your header. Be sure to include today's date, set up your question column and your note column, and resume the video when you're ready to begin. We've been talking a lot about systems, and we've been solving them by graphing them and looking for the point of intersection. But today I'm going to talk about how can we do that without graphing. I've heard the complaints around the class that we don't like graphing always, and I understand that, although it's a very necessary part of algebra. But we're going to look at another method, so solving it algebraically. And 5 seems to be the magic number of how to solve systems of equations. We have 5 steps for solving systems of equations algebraically. First, at this point, we need to make sure that both equations are solved for y. So we want them in that y equals format. We need to set the two equations equal to each other. So the idea is that if they both have an expression that is equal to y, then, and y means the same thing, then we can set those two expressions equal to each other by removing those y's, set the two expressions equal to each other, and then we're going to solve for x. Our third step then, once we've gotten and we've solved for x, is that, well, we need the other part of the solution, we need the y value. So we substitute the x solution into one of the original equations and solve for y. Technically you can do it to both, and it's always a good idea to do that, but one will suffice. The fourth step is that you have to write your solution. So the solution to a system is always that ordered pair, the x and the y value, where those 2 points are equal, and where we see it as a point of intersection on the graph. But you have to write the solution as an ordered pair. And then the fifth step is to interpret the solution in the context of the problem. So, as always, these steps are really important, so please make sure you have them copied down, and then we'll jump into our example problem. So for our example today, I'm actually revisiting the window washing problem. So we had the example from the last lesson about Colby and Ben who are raising money for their East Coast trip. Good idea to jot it down, it's pretty short, but if we remember, Colby and Ben are both trying to raise money for the East Coast trip. Colby washes windows for $15 plus $1 per window. Ben will wash windows for $5 plus $2 per window. And we want to know, when will the cost to use either Colby or Ben be equal? So while we know the answer to this problem, that's actually why I chose it. Like, we know by looking at it on the graph what the answer should be, but wanted to then have that for comparison's sake, this other method of solving it without graphing. So our first step is to make sure both equations are solved for y. If we didn't have equations, we'd have to write those, so that's still an important step. But we have equations for Colby and Ben. And so feel free to look back at your notes or just from here, see if you can remember again those tips about looking for the word per, right? Keying us into the rate of change, the variable before it being our y value, the variable after it being our x. So the equations were, for Colby, y equals x plus 15. I've left off the dollar signs and the 1 because we don't really use that very often as a coefficient. And then for Ben, the equation being y equals 2x, $2 per window, plus the $5. So we have our equations. We always want to make sure we know what our variables mean. So y is our cost to hire them in dollars, and X is the number of windows. Alright, and then now, so here's what, so they're both in the y equals form, right? Y equals and y equals. So what this is mathematically saying is that this expression, x plus 15, is equal to some value y. Here we're saying 2x plus 5, this expression, is equal to some value y. And what we're wanting to know is when will the cost, y, be equal? So we want this y value to be the same for both Colby and Ben. And we know that this expression is equal to that value, and this is. So we can drop these y's off and set them equal to each other. That's our second step. So there ends up being no y's involved. So really we're taking this expression for Colby, x plus 15, and we're setting it equal to this expression for Ben, 2x plus 5. And now we're ready to solve for x. We have x plus 15 equals 2x plus 5. So what I want you to do is pause the video here. We have really strong equation solving skills, so I want you to see if you can solve this for x. What does x equal? Following all of our steps mathematically. And then resume the video when you're ready to check your work with mine. When solving, our goal is to get all the x's to one side and all the constants to the other, and after making sure that's simplified, but because it's in y equals mx plus b form, we know that they're simplified, and so we're ready to balance it and get those x's together. I like to choose the x of the lower term, so here I only have 1, but on the right I have 2, so I'm going to opt to subtract an x off of both sides. Right, make this a 0 pair, and then what's going to happen is I'm going to have 15 on the left, because this makes a 0 pair and goes away, and then 2x minus an x just leaves me with 1x, and I still have that plus 5. So I've reached the goal of having only x's now on the right by subtracting 1 off from both sides, but now I need to get those numbers together, so I want to get it away from here. I have a positive 5, so making that a 0 pair, I can subtract 5. If I subtract 5 from the right, I gotta subtract it from the left, and we end up with x equals 10. So it's looking like at 10x being number of windows, at 10 windows, they would be the same. And remember, we're approaching this as if we have not solved it before, and so we now know that it will be when after they wash 10 windows that the cost will be the same, but we don't know what that cost is. We don't know what our y value is. So the way that we can do that is here in our step 3, we substitute the x solution, and of course you can always test that. Absolutely do. In these videos I like to keep it short though, so I'm not showing that. So you could test to make sure that this is true, but we have solved it by graphing and feel pretty confident. So now we're going to take this solution for x and we're going to plug it in, substitute into one of the equations, and solve for y. So go ahead and do that. You can pick either equation, either Colby or Ben's, plug it in, and see what y equals. Pause the video if you need to do that, and then resume the video when you're ready to check your work with mine. So here, I opted to use Colby's expression. You could have used Ben. If you wanted to go above and beyond, you could use both. So we're taking the solution for x and we're substituting it in. Always remember to use those parentheses for substitution. And so we're saying, what is y when x is 10? And then we just solve this expression. In this case, we just have to add 15 to that. 10 plus 15 is 25. So the solution when they're equal is, well, we know they're equal when x is 10, and if x is 10, y has to be 25. So we're saying, okay, Well, the cost to use either Colby or Ben, that'll be equal when x is 10 and y is 25. So we're ready to write that solution as an ordered pair, right? So kind of what I was just saying here. So a solution to a systems of equations is always a pair, an x and y pair. So we write it as a ordered pair, 10 and 25. And here I like to have it here because it helps with this last step here of interpreting the solution in the context of the problem. And so we know that x is 10 and y is 25, and that represents windows and cost. We've already kind of written this out in our last problem, so I'll go ahead and uncover it. To wash 10 windows, the cost for hiring either Colby or Ben is $25. So that concludes our video today. You want to make sure your notes are complete, but the real idea is this new strategy that we don't always have to graph to solve systems of equations, and that we have this way of setting the equations equal to each other, solving for one variable, and then using substitution to solve for the other, and that can lead us to that same solution, that ordered pair of finding out what are the x and y values that make that system equal. Alright, so make sure your notes are complete so that you have them handy when we are practicing this in class.